right. Working on this, okay, on the signal tracer. So
it's an EICO 147A signal tracer.
Mm-hmm.
And what this thing will do is it's really just a glorified amplifier.
Okay.
But it's convenient, self-contained, and it'll do several things. When it says here the input selector, it has 3 settings here: RF, audio, and noise.
Mm-hmm.
I forget what noise does. We can look it up. All RF does is point to this input right here.
Okay.
All the audio does is point to this input.
Right.
This input is more sensitive than this input.
Okay.
The reason it has an RF input is because back in the old days they used to fix televisions and radios. That's why your daddy had it.
Okay.
And what happens is if you've got what's called a modulated signal, which is a very high RF signal,
Mm-hmm.
very low volume, very low amplitude, but very high frequency, then this probe here actually says it's an RF probe.
Mm-hmm.
It actually has a diode in there.
Okay.
That demodulates that RF. So bottom line is that if you're trying to fix a TV or a radio, there's several stages in the circuit where you might be able to get a signal. You're trying to figure out why nothing's coming out.
Okay.
You can go into the IF section, for example, and touch the appropriate terminal, and if anything's playing, you'll hear music coming out of it or whatever you're playing through it. And so if you get it on the IF stage and you're not getting anything out of the speaker, then it's something after that point in the circuit. You can eliminate everything ahead of that, which is the hard part. The audio input is if you're going to listen, and for organs, you're going to be using mostly the audio input. There are 2 different things here. Number one, let's see, I don't know if we can tell it, but listen how loud this is
Mm-hmm.
versus how loud.
Mm-hmm.
A lot more volume on this one. That's because it's got an extra tube in there to amplify the signal.
Okay.
And so, but this one's probably going to be enough. But if you're trying to get a real low volume on there, then you plug this onto here, screw it onto here. This is an old Switchcraft microphone connector. They used to be real popular in the old days. Now they use XLRs. So we'll go back to RF. You've got to touch the right probe. That's always important. So that'll work on, you can use it for audio as well as RF, but it's designed for RF probe. But then, put it over here on audio. You got what I call, these things are real neat. I don't know who made this, but whoever it is, he did a really good job on it. He really took some time to design this thing.
Mm-hmm.
These are called pin plugs. And all they do is they plug into here. Well, they're supposed to plug into here. They plug into that one. This one doesn't feel like it's tight enough. You know how you go in and retension a tube socket?
Mm-hmm.
You take a screwdriver or a pick or something and you bend them in a little bit.
Mm-hmm.
You're going to want to do that on these 2.
Okay.
I mean, it'll work.
Okay.
See, because when I push this one in.
Okay, it's loose.
The bottom one's supposed to do the same thing. So you just tighten it up.
Okay.
But now we're on the audio. And where this is very useful is whenever you've got a case in point. When you did a service call recently on a B3
Mm-hmm.
and the audio went away,
Mm-hmm.
where in the circuit did the audio go?
Mm-hmm.
You can actually start all the way up at where it comes from into the AO28. You can start at the beginning. You can go to the terminals.
Mm-hmm.
You don't hear anything coming out of a case in point. You don't hear anything coming out of the Leslie. Go up there and touch one of the G terminals. Make sure this is on ground. Touch one of the G terminals. If you don't hear any music coming out of the G terminal, the Leslie can't work because nothing's coming out of the organ.
Nothing's coming out of the organ. Mm-hmm.
That's the last thing before it goes into, probably goes into the kit. Now the kit could be bad. I've never seen a bad kit, have you? I've seen one with bad resistors, but not the bad transformer. They just usually don't go bad. Now, there's one other thing, and trace is the only setting I would use on it. This test amplifier and speaker actually disconnects. It disconnects this audio. See here, your audio is going in, but it's not going to the speaker. And the reason why is if this allows you to substitute the output transformer in this thing, you can substitute it in an amplifier. You have to read the manual on it, and I've got a manual on it. But you've got these various things here. Right here is where you can plug the oscilloscope in. And with that, for example, let's see if we can do that. I don't know if I've got enough. Let's go back over to trace. You don't have a mess like this on your bench, do you?
I got some other mess on it.
You know what? I need that right there is what I need. So we come over here, see if it's big enough to get a signal on it. And that's what that signal, that noise we're listening to, that's what it looks like on an oscilloscope. Now if I were to put a tone in it, it'll electrocute us all. Probably easiest to try to do this. I don't know if it'll work. The noise obviously is me holding it on there. That's what a sine wave looks like. And where that would be useful and what this is looking for is, let's suppose that the organ's real distorted. And you put that on there, and a distorted signal, I don't know the easiest way to do it, but it'll, instead of these being nice rounded curves at the top and the bottom, if it's distorted, those can get flat and ugly. They can turn into a square wave. I don't even think this scope has a calibrator on it. I haven't used that function of it in so long. But that's the purpose of that out, so you can see what you're hearing. And it's probably worth making a cable to plug into there to be able to access it. And it would go from here to ground. And it's all these pin connections. Now, there's one function on here that you got to be careful about. And I've never used the function on it, but the reason I bought me one of these is because I want to be able to do this. I want to make sure I'm telling you correctly, because you're putting it on video, and that means I got to get it right. I don't normally keep it this messy. It's always perfectly clean, but you caught me off guard. You believe that, don't you?
I hear you.
What do you see up there on that meter?
The plus 143.
Plus 143 what? Volts.
That's what that is.
143 volts.
Uh-huh.
So that's why you don't want to play with this thing when you don't know what you're doing. And what we're doing, we're down here, we're on the noise.
On the noise, uh-huh.
Now, what you will do on that, there's an excellent video on YouTube. In fact, I posted it in the group when I talked about the guy's Mr. Carlson, Mr. Carlson's lab. I posted in there. And what that's for is these carbon composition resistors in these amplifiers get noisy. A lot of times people say, I've got a crackling sound. Well, check your plate resistors. Well, this will help you confirm if it's a plate resistor. You can actually take the plate resistor, if it's bad, and put it in there. And sometimes you can tap on it. Sometimes you don't have to do anything, and you'll hear it crackling. And that way you'll know you got the right part. Plate resistors, yeah. I think they should always be replaced, but that's another matter. I mean, it's actually got a built-in watt meter here. Let's see if I've got anything we can test that with. It says it goes up to 500 watts. We do have something here. So there's a watt meter. If we put it over here on the watt meter function, well, it's this one. This bulb is not going to draw enough current because it gets down here. It's a 25 watt bulb, and all the way down it says it's 0, but it starts opening up at about 20. What would be probably 30. 40, 35, 30, 20. It's about where a 25 would be. Now, if I have a
So is that voltage is coming out of this machine?
Yes, sir. No, it's coming out of your machine.
It's coming out of my, and it's feeding back into that.
I'm just monitoring it with a voltmeter.
I'm
reading that voltage. That's all I'm doing is reading it, because what happens is
so putting it on noise.
Noise puts that high voltage on the audio input.
Wow.
So that you can and what happens is that resistors and capacitors in tube circuits are usually under high voltage. When they fail, they often look like they're okay at normal low voltage or just testing with a meter. But when you put high voltage on them like they're going to be in the circuit, then they start acting up. This allows you to simulate it as if it's in the circuit. Now you got to be careful, because that's 150 volts. It's supposed to be 160, but it's just nominal. And if you put a 50 volt capacitor in there and turn it on, you're going to blow up the capacitor. If you put a 350 volt one on there, you're going to test it up to 150 volts, which is better than testing it. I mean, if you look at, this has probably got about 3 volts in it. So when you check the value of a capacitor, for example, or check with a meter like this, you're putting probably 3 volts on it. So it's good at 3 volts. This is accurate at 3 volts, but when it gets up to high voltage, it may be different. That allows you to find out. All right, let's try this. This is out of my dim bulb tester. Bought a bunch of cheap light sockets, and they sure are cheap. All right, that's bright. Now let's see if we can tell how many watts that bulb is. Here we go. What we're doing is we're watching this magic eye right here. So when it starts opening up, see, if you get all the way down, it closes up. All the way up, it's open all the way. And my understanding is that you go up here and with the part where it starts opening up, right there. Can you read where that?
I can't see it, but let me see it here. Is that
Looks like 150 to
150?
me. That's a 150 watt bulb. So it tells you that. Now having said that, in 2022 we do it like this. Actually, it's a 300 watt bulb. So you would have to calibrate that by moving the needle pointer. And that actually makes a little sense on why it didn't work on the bulb as well. But if you look on here, the scale for between 150 and 300 is only about that far. So you'd have to calibrate that. But it does, even then, it'll give you an idea of where you are. Up to about 100, you got a pretty good scale. But now, for example, that light bulb is drawing 278 watts. At 120, 118 volts, and at 2.32 amps. You know what's strange? That's how much current a 251 amplifier draws. That's what a 251 amp looks like as a light bulb. That's an amp more than a 122 amp draws. That's what it does.
All right.
I don't, the other stuff in there, I don't know if you'd want to try it, because these three settings right, these three jacks right here are so that you can actually, for example, if you're servicing a TV like your dad did, and he thinks the output transformer is bad, he can disconnect the three leads going to or the two leads going to the output transformer on the TV. He can connect it to here and to here, or to here, here, and here, depending on which one it is. And if the transformer is bad, he's going to hear the audio coming out of this speaker. It doesn't depend on the TV speaker or the TV output transformer. This is like a substitution box is what this is. It's a neat little device. Since Mr. Carlson did his video on these things, they've become in great demand, and the price has shot up on them like crazy. These things now, in good shape or even untested, are going for as much as $150 a piece. And they're probably going up more than that. Yours is in perfect condition. Yours would get a premium price, I would imagine. Your jack's not even broken. Most of the jacks are broken on them now. But don't leave that turned on. I mean, you're not going to get shocked on here. But if you go over to noise and touch anything connecting to that red one, you're going to get lit up.
Okay. Thank you. All right.
Trace is right there. That knob needs to be moved over a tiny bit too. Neat little device. And what you might want to do when you get home is, and you got, I don't know, a 122 with the amp open and powered up, or if you've got an AO28 that you can get to, you take your schematic, and there are about 3 or 4 spots in there, particularly on an AO28. You figure out which spots to go in there. You take your probes, you go in there, you have something play and set something on the keyboard so there's noise going through it. If it's dead, don't even do it when it's dead. Do it when it's working so you can see what it's supposed to look like. And you go in there and you check about 3 spots, and within about 30 seconds you will know which part of that circuit is a problem whenever you've got a bad one. If you check, for example, at the input of the AO28 and you're not getting anything, then the problem's in the wiring of the organ. I mean, it could be, you know what all it could be. If you go into certain stages in there, in fact, one of the things that I told you you could do with a signal injector, probably need to anyone doing field service calls on B3s should probably have a signal injector, because there's the radio phono input on the AO28.
Mm-hmm.
If you're not getting any audio out of it, the first thing you do is just connect it, just plug it right into that jack. And I could get a schematic and show you, and I'll do it whenever we're not trying to
Okay.
be hard to see on the video.
All right.
But I'll show you on it, and whenever you plug it in, if you hear that tone coming through, you can eliminate everything past that in the circuit as being part of the problem. It allows you to zero in on exactly where the problem is. This sort of will do the same thing in reverse. You got somebody playing the organ, but nothing's coming out. You don't have a signal injector. You can take this and touch it at that point in the circuit.
Mm-hmm.
If music is getting up to that point in the circuit, you'll hear it coming out of this speaker. It's fantastic.
All right.
Love it.
All right. Thank you, Mike.
Yes,
Appreciate
sir.
it. All right.
Let me know how it works out for you.
Will do.
I love it.
Okay. Thank you.